Hello everyone, my name is Faris Iman and I'll be presenting the introduction section of our report on the Nike Air Zoom Pegasus 40. Product design and development or PDD is basically the structured process of turning an idea or customer's need into a real marketable product. It combines different areas like marketing, engineering, manufacturing, management, all working together to make sure a product is functional, high quality, affordable and released on time. PDD is very important because it helps companies stay innovative, competitive and profitable. By following a proper process, business can reduce error, shorten development time and deliver product that meets customer expectation. Nike is a great example as one of the world's top athletic brands. Nike Incorporation found in 1964 and renamed is in 1971. It has built its reputation on continuous innovation in sport footwear. Their Air Zoom Pegasus series show how they use athlete feedback, material science, and sustainable design to improve performance and comfort in every new model. For instance, the Pegasus 40 combines responsive zoom, air cushioning and breathable mesh, and sustainable material, showing how effective design and development translate into real-world performance. In short, product design and development is not just about making a product but about creating value for both the company and the customer.
Engineering design defines not only how a product performs, but also how much it costs. Studies show that around 70 to 80% of a product's total cost is decided during the early design stage. Once production starts, it's usually too late to make major savings. Therefore, cost management must begin with design decisions. Engineering design affects both production costs, like materials and labor, and life cycle costs, such as maintenance or disposal. For example, Nike's Pegasus 40 shows how engineers balance high performance with cost targets. By optimizing the foam and upper materials early, Nike maintained comfort and durability while keeping costs under control. To reduce costs effectively, Nike applies several design strategies in the Pegasus 40. Through value engineering, the team used React foam, which is more durable and energy efficient, cutting long-term warranty and replacement costs. Nike also adopted a platform strategy, reusing the outsole mold across generations to avoid expensive new tooling. The one-piece mesh upper follows, designed for manufacturing, which reduces material waste and speeds up assembly. Finally, concurrent engineering and digital simulation allow designers and manufacturers to work together from the start, solving problems early and cutting R&D expenses. In brief, these approaches show how thoughtful engineering design can improve cost efficiency without sacrificing quality or sustainability.
Okay, my name is Ku Xiaojun and today I'm going to talk about design for manufacturing or DFM using the Nike Pegasus 40 as examples. So what is DFM? DFM is a design approach that thinks about manufacturing from the very start. It makes sure a product can actually be made efficiently. So the goal is to reduce the cost, save time, minimize defects and still keep high qualities. In early decisions like materials choice or part complexities have a big impact on the products later. Why is DFM is important? When we using the DFM help Nike makes high quality shoes faster and cheaper. It also reduces the waste and support sustainability. So at the same time, it balances the performance with manufacturing, so the shoes feel great and can be produced at scale. Through DFM, we found that Nike has applied 5 DFM principles in Pegasus 40. So first is process. The midsole and outsole use injections or compression moldings, making the production faster and precision. Second, design. The upper uses integrate engineering mesh, reducing stitchings and parts. Modular assembly allows upper, midsole, outsole, and insole to make separately, then assembly quickly. So third is materials. The React foam and Zoom air cushioning provide durability, comfort, and shock absorptions. Standardize the materials to ensure consistent qualities. The fourth is environments. So the light wheel, recyclables, and tear-resistant materials are used. The shoes can perform well on wet or uneven surfaces, reducing environmental impacts. The fifth is compliance and testings. All materials are lab tested for safety and performance. Supplier factories are audited. Nike also used field tests like runners to improve fit, cushioning, and responsiveness. So in summary, these DFM strategies make the Pegasus 40 cost efficiency, high quality, sustainable, and easy to mass products while performing well for runners.
For this part, I will explain what QFD and House of Quality means using the Nike Air Zoom Pegasus 40 as an example. QFD is the method that helps us to turn customer needs into clear design and engineering specifications. Instead of just guessing what runners want, we systematically capture their expectation and link them into technical fictions. In our case, the product is Nike Air Zoom Pegasus 40. Runners want things like soft, protective cushioning, a stable and lightweight ride, good breathability, durable grip, and daily comfort. The House of Quality is the main tool in QFD. It is a metric that connects the what's and the hows. The what's are what runners say they want, and the hows are what designer can control, such as a midsole foam type, firm hardness and thickness, heel top drop, shoe width, upper match design, and outsole rubber. For the House of Quality, we follow these three simple steps for the Nike Air Zoom Pegasus 40. First, we found the customer requirement, the what's. From review and product info, runners want a good cushioning, a stable and light ride, a breathable upper, durable grip, and comfort for daily wear. We also give each of these needs an important rating. Second, we define the engineering characteristic, the hows. We turn each need into something that we can design and measure. For example, cushioning is linked to the midsole foam type, hardness and thickness and the air zoom unit. Lightweight is linked to the total shoe mass, breathability to the mesh and verticalizations, and durable and grip to the outsole rubber and tread pattern. Third, we set the relationship and priorities. In the HOQ matrix, we mark if the link between each what and how is strong, medium, or weak. Then we combine this to the important rating to see which technical factors matter most. For the Pegasus 40, midsole foam and outsole design become the key priority because they are strongly affect cushioning and durability, which is very important to the runners.
Hi, next I will now show how HOQ converts what's into hows. Taking Nike as examples, Nike apply this process in designing running shoes. The engineers begin by identifying what customers value most, for example, comforts, breathability, and durability. They then focus on specific technical features that can be adjusted or measured to address those needs, like the Zoom air cushioning, React foams, and the engineered mesh upper. In the House of Quality diagram, we can see how these elements are connected. Comfort and cushioning have strong relationships with both the Zoom air units and React foam midsole. Breathability is strongly linked to the engineered mesh upper, which help with airflow and keep the shoe lightweight. Meanwhile, durability is moderately related to midsole foams and outsole materials that extend the shoe lifespan. At the top of the matrix, we can also see the rooftop section show how these technical features interact with each other. For example, improving cushioning may slightly affect width of breathability, and at the bottom, the relative importance values show which features matter most to the customers. So we can say that HOQ help Nike see which feature matter most.